So let's look at Chapter 5. We are actually doing 5.1 and 5.2 within this section. 5.2 is systems with 3 equations. Okay, so yes, I know you know how to use a matrix in the calculator to solve. That is not what I'm testing. That is not what I am wanting you to show me how to do. So you can use your calculator to check it, but I'm going to teach you how to solve it without the calculator. Okay, so don't go straight to the calculator and just put it in. That's not the method I want you to use. That's my disclaimer for this. So we are going to decide whether an ordered pair is a solution. We are going to use substitution and use addition, and then identify systems that do not have exactly one ordered pair solution, and then solve problems using systems. So whenever we have a system of equations, so we're going to start out with 2 variable, 2 equation, and then 5.2 is 3 variable, 3 equation. So a linear system that has at least one solution is called consistent. And a linear system with no solution is called inconsistent. And a solution to a system is an ordered pair x and y that solve the system equations. So let's look at our first problem. Determine whether ordered pairs are solutions of a system. So to determine, we're going to plug in an x and a y. And you have to check both equations. So I'm just going to plug it into the first one. You can put this in the calculator, or really it's easy just to work it out. So it'd be 2 minus 6 equals -4. 2 minus 6 is -4, so that is true. So the first equation is true. Then you would do the second one. So 2 times 1 plus y, 2 equals 4. 2 plus 2 is 4, so 4 equals 4, so it is true. So we can write 1, 2 is a solution to the system. Okay, let's look at the next one. Determine if that ordered pair is a solution. So we'll plug it in. So 2 times 7 minus 3 times 6. See if it equals -4. 2 times 7 is 14. 3 times 6 is 18, so minus 18. 14 minus 18 is -4, so -4 equals -4, so that is true. But we want to make sure that the other equation is also going to have 7, 6 as a solution, so we'll plug that in. So 20 does not equal 4, so that is not a solution to the system. So we can write that 7, 6 is not a solution to the system. To solve a system by substitution, so this is the method. So solve either equation for one of the variable, and then you can substitute that expression into the other equation, and then solve for one of the variables, substitute in the solution to solve for the other variable, and then make sure to check your x and y to make sure that is the solution to the system. Okay, so we would look at this and we would see which one would be easier to solve for one of the variables. Be the bottom one. It'd be easy to solve y. So we are going to solve for y on this 2x plus y equals 1. You can pick either one. You're looking for the easiest path. And so right now the easiest path is to find what y equals. So minus 2x. So we have y equals negative 2x plus 1. And now we're going to substitute this into the other equation. Sub in y. So it's going to be 3x plus 2, parentheses, negative 2x plus 1 equals 4. And when I do that, I just have one variable, and I can solve for x now. So I do need to distribute. So I have 3x, and that would be 2 times a negative 2, negative 4x plus 2 equals 4. Then I could combine these to get a negative 1x plus 2 equals 4. Minus 2. Negative 1x equals 2. But I can't have a negative x, so I divide by a negative 1. So this gives me x equals negative 2. And then I use this to substitute back in one of the original equations. So it would be easiest to use this one. So I'm going to substitute this in right here. So it's now 2 times a negative 2 plus y equals 1. We're going to solve for y, so negative 4 plus y equals 1 plus 4. So y equals 5. So then we're saying that our proposed solution is negative 2, 5. But then you want to substitute it in and make sure that is true. You can use your calculator to sub in. I'm just going to sub it in down here. So 3 times, this is my x, so 3 times a negative 2 plus 2 times 5 equals 4. 3 times a negative 2 is negative 6. 2 times 5 is 10, so plus 10 equals 4. And that's true. 4 does equal 4. So far, so good. Then you need to check the next one by subbing in to the 2x. So 2 times the negative 2 plus 5 equals 1. Negative 4 plus 5 equals 1. Negative 4 plus 5 is 1, so 1 does equal 1, so it works. So this is my solution. So then I would say I'm done with that. So that is using the substitution method. Okay, let's do the addition method. So with the addition method, we are going to line them up and write them both as standard form ax plus by equals c. So they're both going to be listed like that. And you're going to find a way to eliminate one of them by adding them. Or that's elimination. So it says multiply either equation or both equations by appropriate non-zero number so that the sum of the x coefficients or the sum of the y coefficients is 0. Add them together and then solve for one of the equations. Then substitute one of them in to solve for the other. And then you want to check them. Okay, so let's look at this example. So 4x plus 5y equals 3 and 2x minus 3y equals 7. So 5 and 3, I'm going to have to multiply both of them by something to get rid of the y's. But 4 and 2, I could multiply this 2 by a -2 to be able to cancel them. Because then I would have a 4 and a -4, making it 4 minus 4, giving us a 0 there. So I'm going to multiply this whole thing by a -2. I'm going to rewrite this. So rewrite this before I multiply that. And then I'm multiplying this so that I can get rid of my x. So this is -4x plus 6y equals a -14. So what I did was I multiplied -2 times 2 to get -4, a -2 times a -3 to get a +6, and -2 times a 7 to get a -14. Something that a lot of people miss is that c value. They forget to multiply that one. So now if I add these together, 4x minus 4x is going to be a 0x. So I don't need it anymore. So now all I have is y's, and I can solve for the y. So 5y plus 6y is 11y. And then 3 minus 14 is -11. And then we can divide by 11. And we get y equals -1. So that's one of the variables. We've got to find the other variable. So we're going to sub in the -y for one of the other equations. Which equation would be easier to deal with? The top one? Why the top one? Yeah, no negatives. So we'll sub in the -1 for that y value and solve for x. So I know y is -1, so I'm replacing y with -1 here. So I get a 4x minus 5 equals 3. So plus 5. So 4x equals 8. Divide by 4. X equals 2. So our proposed solution would be xy, so 2, -1. We do need to check and make sure that that is going to work on both. So we'll do 4 times x plus 5 times y and see if it equals the 3. And you can put this in the equation. It'll give you a 0 or a 1. I think we've done that. So it'd be 8 minus 5 equals 3. And that's true. And then we could do the other equation. So 2 times 2 minus 3 times a -1 equals 7. So that'd be 4. -3 times a -1 is +3. 4 plus 3 is 7, so it's true. So our solution, 2, -1, is our solution. Okay, with systems of equations, we can have 3 different answers. So we can have one solution, that's your intersect, exactly one solution. We could have no solution, that's when they're parallel, they have the exact same slope. And then infinitely many, the 2 lines are identical, so there is no solution there, or infinitely many. So this is when you get a true statement at the end, and this is whenever you get a false statement at the end. So like 10 equals 0. True statement would be like 5 equals 5. Okay, so let's look at example 5, a system with no solution. So how should we work this out? Just addition? Okay. What could we do? Okay. Just by positive 2? Yeah. Because we already have the negative down here. So then I'm going to rewrite this one as when I multiply it. So I multiplied 2 times the 5, 2 times the 2, and 2 times the 4. Okay, and then rewrite the other one. And then when you add them, that cancels and that cancels. So we have 0 equals 15. Yep, false, so it's no solution. So that means whenever it's no solution, they never intersect. They are parallel lines. So this actually gives you what they look like. So it says, in solving the system, we found the solution is empty. The lines are parallel, do not have an intersection. All right, let's look at the next one. How should we solve this one?
Well, it's first, let's get everything on one side.
Ooh, it'd be easier just to substitute. Yeah. We can substitute x. So this goes in for x. So it's going to be 5 times 4y minus 8 minus 20y equals negative 40. So distribute. Yeah, 20y's cancel. We just have negative 40 equal negative 40. That is true. So that means infinitely many. Same line. Okay, so this shows how they would be if they were graphed. Yes. Okay, let's look at an application problem with revenue and cost. So a company produces and sells X units of a product. R of X is called your revenue. What is revenue? Do y'all know?
What you mean?
Yeah. The money coming in. Cost. What is the cost?
What you spend?
Yep. How much you're spending. So this is money that's going out. And revenue is how much money you are making. That's how much is coming in. A point of intersection of the graphs of the revenue and cost function is called the break even. So you got to find out. So there's actually use of this kind of problem in the real world because businesses want to find that break even point and then they want to surpass it. They want to start bringing in money instead of input and output being the exact same or output being a whole lot more than what you're bringing in, then you're losing money on your business. So that break even point is really important for businesses. So here is an example of a cost and revenue functions. So a company that manufactures running shoes has a fixed cost of $300,000. Additionally, it costs $30 to produce each pair of shoe. They're sold for $80 a pair. Your cost function is found by doing your fixed amount plus how much you produce the shoes for, which is $30 a shoe. And then your revenue is 80 times however many shoes you sell. So in order to determine the break-even point, we can set up a system of equations. So whenever we have a system of equations like this, then we are going to use substitution. So go down to this one where we have a little bit of room to work. They're both set equal to y. So what we can actually do is set them equal to each other. We're wanting to find out, where does it break even? Where are they the exact same? So 300,000 plus 30x equals 80x. Where is the cost going to equal the revenue? And that's your break-even point. So just solve that. So x is, let's see, where does it use x? It's the amount of shoes, right? So after 6,000 shoes, you would break even. It takes 6,000 shoes to break even. So 6,000 shoes to break even. Which, if we want to know how much that'll cost, then we would plug it in. An easier one to plug it in would be this 80x. So we do 80 times the 6,000. $480,000. All right. The next example, I'm not going to actually work it out. This is very similar to what we were doing in the beginning. This is starting 5.2. Determining whether order triple defines a system. So your first number is x, second is y, third is z. Yeah. So I'm not going to solve this one because you can sub it in and check that yourself. You're going to have a couple problems like that on your assignment.
Easy peasy.
Okay. So let's go to our last example, though. All right, let me read the instructions for you. Y'all quiet down. So if we have a system of 3 equations, 3 variables, we've got to be able to reduce it down to 2 equations, 2 variables, and then work through that using either addition or substitution, and then take it back to your 3 variables. So what I want to be able to do is I want to be able to use 2 of the equations at a time to get rid of one of the variables. So I'm going to use these. No, I'm going to leave it like this. Yeah, Z's already canceled, right? Oh. So let's look at it. So I can use addition to get rid of my Z's. So now I have one equation that has 2 variables. Now I want to do the same thing with two other equations. I can reuse one of them. I think the first one and the third one would work because the Z, I want to get rid of the Z again. So I can multiply this times 2.
You can't just use that one and the third one?
No, because I wouldn't get rid of Z's, because whenever you add it, you would get a 1Z. So I'm going to multiply this first, and then I'm going to add it to my third. So this is 2x plus 8y minus 2z equals 40.
Once you start going for one number or one letter, you can't switch letters, right?
Right, exactly. So because I chose to get rid of z first, I'm gonna have to get rid of z in a second grouping so that I have two variables with two equations.
So then with that equation, you would use the third.
Yes, I'm gonna use this one now. Because look at my z's. Do you see how the z's cancel? Yep. That whole grouping cancels. So now I have a 4x plus a 5y equals 24. All right, so now I have two variable, two equations. So I'm going to put them on top of each other. That's my second one. So see this one? So this came here, and this one went here. I want to subtract it. So what I'm going to do is I'm going to change the sign of all of these to subtract it. That's the same thing as multiplying -1 times everything. Because what can I get rid of? Because they're the exact same, just not opposites yet. Yeah, that 4. So the reason why I'm subtracting is so I can take that 4x and subtract them to get rid of them. So then I can cancel them.
Y equals 4.
Yeah, so I got y equals 4. That's the start of it now. But the rest of
Now
it's
we gotta
easy now.
plug it in.
Now you got to plug it in.
Come on, guys.
Where are we going to plug this
Don't be
in?
silly.
I would go to one of these.
The 4x.
Go back to where you were. So 4 times 4 plus 6 times y equals 28. 4 times 4 plus 6 times y. Oh! I plugged in the wrong one.
Oh my gosh, now I need your wide out.
Me too.
You get 0.
Hold on. White out.
Extra y. No extra y, dude.
It was a tiny mistake. It was tiny. So then I have 4x plus 24 equals 28. Then subtract 24. 4x equals 4, divide by 4. So x equals 1. Yeah, so now we have the x and the y. So we want to plug it into one of the original now. Which one would be the easiest to deal with? It really doesn't matter. Yeah, the middle, because they're all positive.
What is z?
We don't know. That's what we're going to find. So x is 1. Y is 4. We don't know what z is. So we're finding it using substitution. Don't confuse your z with a 2. Be careful with that. Yep. Draw a little line in the middle.
Next slide. Yeah.
Okay, so you write your answer x, y, z.
1, 4, -3.
Use substitution to check your answer. Go ahead and do that. And then your assignment's up here.
That was